Hey listeners, welcome to the fourth episode of the Lab Report, Reaction in Action. With me today is Professor Grigoriy Yablonsky, an expert in chemical kinetics. How are you doing today, Professor?
I'm great. It's good to see you too.
Professor, to start us off, how many reactions are there, and what are some differences or features of each?
That's a great question. In introductory chemistry, we usually group reactions into a few main types to make them easier to understand. One common type is a synthesis reaction. This is where two or more substances combine to form a single new substance. Another is decomposition reaction, which is essentially the opposite. One compound breaks apart into a simpler substance. We also talk about single replacement reaction, where one element replaces in another compound, and double replacement reaction, where parts of two compounds swap partners. And finally, there are combustion reaction, which involve a substance reacting with oxygen and releasing energy, often heat or light. These categories help chemists quickly recognize what's happening when substances react and how atoms rearrange.
That's very fascinating. To stay on this topic, balancing equations is a huge part of what you do. So can you explain to the listeners how you do this and why it's so significant to your work?
Absolutely. Balancing chemical equations is essentially making sure the number of atoms on each side react is the same. This comes from the law of conservation of mass, which tells us atoms can't create or destroy during a reaction. They are simply rearranged. So when chemists balance an equation, we adjust the number in front of each substance, called coefficients, until every type of atom appears equal in amount on both sides. For example, if the hydrogen reacts with oxygen to form water, we balance it so the same number of hydrogen and oxygen atoms appear before and after the reaction. It's important because a balanced equation tells us the exact proportion substance react in. This helps chemists predict how much product will form and how much reactant is needed, whether we're studying reactions in the lab or designing industrial processes.
You mentioned the conservation of mass. Could you elaborate on how you implement this law?
Of course. The law of conservation of mass tells us that in any chemical reaction, the total amount of matter stays the same. Atoms don't disappear or appear. They simply rearrange into new combinations. When we apply this law in practices, we make sure that the number of each type of atom is identical on both sides of a chemical equation. That's exactly what balancing equations accomplishes.
Thank you so much for joining us today, Mr. Yablonsky, on this episode of the Lab Report, Reaction in Action.